throughout this course, we're trying to bring you some examples of not just marketing problems, but also problems that tie together IT and marketing. And let's say that in our data's case, we have a set of data which is kind of compiled by our IT people, which the marketing people have asked for. And what it gives us is we're selling our product on the website, and we are having them use a trial period after which they will become subscribers of our product. And we want to know, how do they make the decision? So here it is. We have different referrers, which essentially tells us from which site did they end up on our site when they started signing for membership. So we have people coming from slash.org, Google.com, Dig, Kivitopes, directly typing in our link, so a bunch of different stuff. There are people who come from different locations as well, UK, USA, France, New Zealand, and we've also asked, so our kind of always, it's a question of what information to ask for, because information gathering costs money for the people to write the queries up. So we've asked them, have they read the frequent asked questions on our site, and how many pages they viewed on our site previously before coming. So kind of again aggregating all those server logs that there are. Those server logs record everything, but we just asked, please aggregate it for us, tell us what are the pages viewed, and that's all from the server logs. So always with a bunch of data and with big data, you have a question how to aggregate this stuff. And then finally, these are the past clients. So they've chosen the trial period, and some of them have chosen the premium membership after the trial period ends. Some of them have chosen the basic membership, some non-membership. So what we want to do is to model their decision. How did they come up with that decision? So let's try to do that with SAP PA now. Let's go to SAP PA now. Let's take text file and choose, I've already pre-chosen this decision trees. And here it is. It tells us that the first column has column names in it. And now we're going to create this data set. We have to go from visualize to predict and choose algorithms. It's quite straightforward. We have to choose RCNR3, which is SAP PA's algorithm for decision trees. It's essentially using R part. So this is the name of the R algorithm it's using. So it's turning straight to R in here. And what we do next is we go to settings of it. And we say that we're using decision trees for classification. We'll do regression later. We'll kind of wanting it to give us the results as to what it thinks the classes are. And the target variable is the service chosen. So that was the last column in the data. And the rest of it is the input variables it bases the decision tree on. And we get the predicted values out. So that's the essential drill of it. And here it is. We're ready to run. So let's have it turn to R from SAP PA, and here are the results. Let's look at what decision tree gives us. So first of all, the first person who came from slash.org didn't sign, and we didn't think it would sign. Premium was predicted for the second user correctly, basic correctly, premium correctly, and then we made an error with a direct referee, thinking that he would select basic service, whereas he really did select direct service. So a number of options here. But let me show you some even more interesting things. First of all, let's take a look at the decision tree. So it turns out that as the decision tree was built here with kind of default settings, so we didn't select anything regarding how to build a tree from the program. With those default settings, it made, well, we had three classes, basic, none, and premium. And it made the distinction first by the referrer. So it turned out that the referrer was the most important part. And if it was Google who referred us, then it was the premium subscription that was taken. There were a few errors along the way, so this kind of doesn't give us a pure class of only premium subscribers, this Google referral. but it gives us very many premium subscribers. So kind of Google is the way to look for in here, for having those hits. And then if the referrer was direct or dig or kivitable or slashdot, we went to the other branch. And note that this decision tree can only branch into 2 at every step. So it turns out that as the second thing, it also selected referrer, and now it says that if it's slash.org, then those people don't buy our product. So it's kind of an informative site there, but it's kind of non-profit. So I guess that's the reason. And now if it's the referrer was direct or dig or kivitops, then we have a basic subscription more out of it than none. So you can see that this is the decision tree that was built for us. It gives us like the answers, but very importantly, it also tells us that the referrer, according to this data, and of course it's a kind of small and play data set, but referrer is the most important dimension to base our decision by. So for instance, if it's very expensive for us to gather this location data, or if we want to leave some dimensions out of our data set in the future, it might be something we can do based on those decision trees. Besides the tree itself, another output of the decision trees is confusion matrix. You can see here that there are 3 possible outcomes: basic, now, and premium. And on the main diagonal, the number shows how many times basic has been classified as basic, or none as none, or premium as premium. Whereas we can see that the actual none was classified as basic predicted 3 times, or actual basic was classified or predicted as premium 1 time. So such a matrix which really informs us where does the system make mistakes. And down here under derivatives, there are a number of for basic, now, and premium, there are a number of indicators: precision, sensitivity, specificity, negative prediction, that that we can also calculate. The thing is that that they're all basically telling us how the confusion matrix is doing. So for instance, here you see that that for actual basic we have 5 out of 6 correctly found, and the true positives there is 83.3%. So all those measures down there are, the lower the measure is, or this measure here, for predicted none, there are actually 3 out of 7 correctly classified, 46.86%. So those numbers you will also find down here, and basically the higher the number, the better the result is. We're not going to go very deeply into that. Let's go back to our slides and talk a little bit more what you can do with decision trees. So first of all, here is a site from the New York Times webpage which considers the options in case of which Obama would have won the 2012 elections, and in case of which he would have lost them. So here you see that the tree that emerges in here has 431 ways for Obama to win, considering the battleground states, and 76 ways for Romney to win. And it's basically what has been selected here is like first comes the most important: Florida, then Ohio, North Carolina, Virginia, Wisconsin, and so forth. And what's been activated here on this tree is this particular point here, which essentially gives us such an option that Obama wins due to the fact that Romney wins Florida and Ohio, and then Obama wins North Carolina, Virginia, and Wisconsin, and altogether this guarantees that Obama wins. So naturally, such decision trees were used in electioneering as well. Now, this is an example of another decision tree, maybe a bit too big one, so we'll talk about cutting down those trees in a second. which essentially takes a look at a number of fruits. So you can see when the color is green and diameter is bigger than 6 inches, you've got your watermelon. If it's between 2 and 6 inches, you've got apple, and less than that, you've got grape. So essentially, you can see that again. The tree is able to only split into 2 parts. So if we have like many ways to consider the diameter in a row, then we just have to make 2 splits. And furthermore, if color isn't green, if it's red, and if diameter is bigger than 2 inches, it's again apple. And if it isn't, then if there is a stone, it's a cherry. If it isn't, it's a grape. And the final part of the decision tree looks at whether the shape is round. If the color is not green and not red, then it might be, if it's not round, it's a banana. If it is round and if it's above 4 inches, then it's a grapefruit. Other than that, smaller diameter is a lemon. So such a decision tree. Now the question is, when does the tree get too big and when to cut it down? We already saw a little example of that earlier on, but here it's called actually pruning the trees. Pruning, if we speak about the algorithms, the pruning is done either before or after growing the tree, but that's actually not very important here. What's important is that out of this big tree, and I'm not going to go in detail into what's being considered here. The options though are satisfied and not satisfied, and then there are a number of variables which are being considered. And it turns out that if you dwell on this tree in a longer way, you can see that this upper part here is sufficient. So otherwise it would already be kind of overlearning. So we can configure the pruning with some parameters when we run it with the SAP-PA. And here you see that it essentially divides into satisfied, divides into 2 by this parameter, and then furthermore by this parameter into 4. So we have those 4 options, and it essentially gets the satisfaction to 90% satisfied, or 30% satisfied, 80% satisfied, or 25% satisfied. So all such different options are considered here already. These are the percentages of population of this 100%, as we showed earlier. So essentially, you can see that already at this level, the tree is sufficiently sophisticated. So there really is no need for growing that elaborate tree, which kind of would be overfitting. And there is, of course, the option of underfitting, which just means that the tree is too small. Before we consider more specific examples with SAP tools, let's talk a little bit more about theory. So once again, the RCNR is the algorithm of SAP-PA, which uses actually R as R part as its main constituent. And now the question is, what are the pros, and later what are the cons of this algorithm? Just for you to know what issues come up with decision trees. First of all, it is a good choice for most classification problems, and it can deal with both numerical and nominal values. So numerical and nominal means numeric is like our pages visited in our decision tree example, and nominal is Google/.kiwi dots and direct. So it can deal with both these values. It can also deal with missing values, and that's an important thing because missing values are going to pop up in our databases and how to deal with them. It's suitable for both large and small data sets, so especially large, of course. So we have the option of really running a lot of data through it. And interpretation doesn't require specific mathematical knowledge. So that's a good side always of considering decision trees. Now, what issues might come up that are cons of RCNRR of SAP-PA? So first of all, this algorithm tends to, and you should note and be wary about that, it tends to favor continuous or discrete variables. So if you have your numbers, pages visited, or variables where you have many countries from which the users have come, then it tends to favor these instead of just, for instance, if there are only a few sites that people have come from, and mostly from different countries. And it tends to favor those countries somehow over the sites, so you should be wary of that. It's also sometimes may over or underfit the problem, so you need to configure it for it. And small changes in the data might bring with it large changes in the tree structure. Now, this is really something that may bug you, because you make a small change in the data and all your reasoning process could change. So something that you should be wary of while using decision trees. And of course, if you build too large of a tree, it's hard to interpret and to use. Let's take one more step and mention that there are different criteria actually which you can choose from while building the trees that will make the tree growing to stop. And make the decision on how the tree kind of grows on which branches. So these are, and you don't have to remember these. I'm gonna just list them for 1 second, and you may always come back to this when you're all deeply interested in decision trees. So these are entropy, Gini impurity, chi-square statistic, gain ratio, variance, standard deviation, mean absolute error. So you see a lot of variables to consider, or a lot of criteria to consider. And there are also many algorithms for decision trees. Now, SAP PA uses rpart, and we also have C5, which is a 50, which is a development of ID3 and ID4.5. CART is the one that's actually being used. It's a package rpart, so it's the algorithm name is CART. J48 and C3. So a lot of algorithms as well. But once again, not to remember, but just to know that there's a reference point to turn back to if you're deeply interested.